Hey everyone, how's it going? Back for another day. We're doing an hour early today because I've got an appointment I can't move in our usual slot, so just me today. I think I said 2 days ago, well, I hope that I get some more sleep for tomorrow. I did not get more sleep for yesterday. I did not get more sleep for today, so I'm running on like 3 days bad sleep, so let's see how we go. Day 7. Okay, no more space left on device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device the elves gave you has problems with more than just its communication system. You try to run the system update. System update, pretty please with sugar on top. No space left on device. That's what my machine is like constantly. I just have full hard drive. I've got 8 terabyte storage NAS sitting on my desk, which is also almost full. I have a problem. It's just like, if you have storage, I'm pretty sure the amount of space you use just expands in order to fill the entire hard drive. That's how it works, right? Hey Vagrant, hey Visa W Gray. So perhaps we can delete some files to make space for the update. I actually did that this morning. I use WinDirstat. It's like a nice way of scanning all the files on your hard drive and visualizing them and telling you that OneNote is taking up 60 gigabytes of space with its cache. That's actually happened. Ugh. Just Gray's fine too. Hey Gray. You browse around the file system to assess the situation and save the resulting terminal output, which is your puzzle input. Oh yes, I love this. Okay, so we've got like a terminal typing in, changing directories, ls, and then getting, I assume this is file size, file name, directories. Okay, this is great. The file system consists of a tree of files, plain data, and directories, which can contain other directories of files. The outermost directory is called slash, or root. You can navigate around the file system, moving into or out of directories and listing the contents of the directory you're currently in. Day 25, we'll have to implement a Unix clone. Yeah, sounds about right. Within the terminal output, lines that begin with $sign are commands you executed, very much like some modern computers. CD means change directory, and this moves in one level, this moves out, this goes to root. Using encode. Yeah, I remember encode from a few years ago. That was fun. Ls means lists the directories. This is file size, this is the file name. This contains directory named XYZ. Okay. So creates like a tree, kind of like that. Makes sense. Since the disk is full, your first step should be to find directories that are good candidates for deletion. You determine the total size of each directory. Total size of a directory is the sum of the sizes of the files it contains, directly or indirectly. Okay, we're doing a tree. Total sizes of the directories can be found as follows. Sum up the sizes. To begin, find all the directories with a total size of at most 100,000. Then calculate the sum of the total sizes. Okay. Seems straightforward enough. Let's get started. Whoops. Okay, new day. Day 7. So we're going to make a tree. Have a node. We can probably just do with one node for directories and files. So a node is going to have a name. A node is going to have a file size. A node is going to have children. Vector. We use unique pointers. Vector of unique pointers to nodes, children, and we're going to be going up directories, so we also need a pointer to parent. Okay, so this will be our node. So we'll read in our input. We'll just read it into a vector, and then step down. No, we don't need to read it into a vector. We can use a just an input range TL get lines. Okay. So lines is TL views get lines of our input, and then actually I will stick this into a vector just so it's easier to deal with. Okay, so now we've got our lines in a vector. So we're going to just go down our lines. So let's have a think about this. So we're going to go down our lines. If we see CD, then we're going to go to that directory. If we see an ls, we're going to then read up until the next line, which starts with a $, a struct, and that's it. So since we're going to be like doing that, I think what we want to do is get an iterator to our vector and deal with that. It'll be easiest to deal with that state if we actually stick this inside a class. So let's call this command line. Okay, so our command line is going to have a unique pointer to our root, and it's going to have a iterator which points to actually the current line, which is going to be this vector string iterator. Okay. Let's just have a process which takes in our iStream and does all of this stuff. Okay, so just be easier to deal with our state this way. All right. When we initialize our command line, we're gonna do, can we just stick this here, std make unique node, and we'll give this a couple constructors. One for directories, which just takes names. One for files, which also takes a size. it's going to default to 0. So we'll make a unique node with slash as our name. Okay. So set this to null pointer. While our let's set current to begin of lines, while current is not equal to end of lines, then we're gonna do all our processing. Okay, so has it ever been considered to make the open bracket, close bracket optional if the constructor body is empty? You mean like this? I don't think it has. I could be wrong, but I imagine it just makes more parsing issues. Okay, so at this stage, our lines should consist of $, and then the command. So we can do commands equals split because I've got a little split helper, split into std strings, current on space. Okay, and then if commands 1 equals cd, then change directory with commands 2. Are only 2 commands, cd and ls? Yeah. Else. List dir. Okay. We also want to keep a pointer to our current directory, which is going to be initialized to root. Okay, so if we change directory, this is going to take a name, and we're going to look among the children of our current directory. So what the possibilities, right, are if name equals slash, then current dir is root. If our name is dot dot, then our current directory is the parent of the current directory. Otherwise, we are going to look in the among the children of the current node. So auto node equals it ranges. Let's get algorithms header. Gonna find if current directory children, find among our children return if node.name equals name. Capture name by reference. Actually, it's a string view, we can capture it by value. Okay, so this should find the node, the child node, whose name matches what we're looking for. And what if, is it ever the case that we change directory into a directory which we have not seen in ls yet? I'm not going to make that assumption. So this could be, returns an iterator. So this could return the end of the range. So if iterator equals just end of our children, i.e. we didn't find that node, then we're gonna allocate a new directory. Let's call it make dir. So this is gonna do current directory dot children, push back, just to make unique name. Okay, so if we didn't find that directory, then we're gonna do make dir with name, and then let's get it to return us a pointer to the new directory. Make a new node. If we're going to return the pointer, we need to do node.get before we do a pushback, because we need to move our new node. And then return node p. Okay. So in that case, current dir equals make the new dir. We might just written all that code for no reason. Like, it might never actually occur that we change dir into something we've never seen from the ls. Otherwise, our current directory is that. Okay, so that should deal with change dir. List dir. So this is where we're going to be building our tree. Now, we need to find the size of all the directories. So we could do this in a big batch at the end, where we go through and find all of our root nodes in our tree, and then propagate the sizes up. But I think it'll be easier if we just do it while we're working. So I need to do ++ current here. So when we do a list dir, we'll be pointing to current. So this should take us to like here, basically. So then we do a split equals I'll call this entry. Split into strings, our current line on spaces. So now if entry 0 equals dir, then we're going to make a directory with entry 1 as the name. Otherwise, we're going to make file with entry 1 as the name and entry 0 as the size. And we'll convert this to an integer. So this, we'll make this return a node as well. Make file, name, and size. Okay, so this is going to basically do this, but we also give it this, oops, when we create this new node, we also give it a size, and then we want to propagate this back up. So while our, let's say, we can do for loop here for parent equals we're not linking in our parent nodes, are we? We need to make sure we do that. These should all take node star parent. Okay. So when we allocate a new node, then we should pass the current directory as the parent. Okay. So when we allocate a new node, the size, our parent is going to start with the current directory. Then each iteration, parent equals parent. Oh, sorry, that's the last one. We keep going until well, parent is not null. Okay. And while we do that, we are going to do parent size plus equals new node, or node p size. Does some unique pointer.get give you a pointer to the thing without ownership? Yes, exactly. Okay, so that should set all our sizes. And cool. This looks decent enough to me. This needs to be a loop. Thanks for the follow, Chip Collier. So this is going to start off, we do plus plus current to get us to the start line, and then we do while so we can do for, well, current is the front of our current, yeah, we can do this, is not $. We want to keep reading lines until we find $. Okay. So then we will be, we'll end up here. We're actually incrementing current too many times, so we can walk back one at the end here. Not the nicest code, but hey. Alright, so that should build our tree, and then we want to walk our tree and find the sizes which are less than 1,000. Maybe we can write a generic tree walker function here. So we're going to take this, we're going to do walk tree, which is going to take some function. We can make this a member function. Did I set the visibility of all this? I think these are the only ones which need to be public. Okay, walk tree. So what we will do with this is we'll start at our root node, and this will be a recursive function. So we can say node star equals root dot get. Right, I call it root. Yes. So we start at root, and we're gonna call our function on our node. Call this current. Gonna call our function on our node, and then for each child in current children, we're going to call walk tree on with f and child. Okay. Now, you know, we can pass this as a reference all the way down, which will let us do some shenanigans with lambdas and whatnot. So then the idea here being that we do command line cl.process in, which builds up our tree. Then we do cl.walk tree with a lambda, which has some state. You know, this will be nicer as a struct. We'll call this part one walker, and this is gonna have a vector of what is it we want to collect. Oh, it's just the sum of the sizes, which are at most 100,000. Actually, we can do that with a lambda. Walk tree with a lambda, which has a member called size, which takes a node pointer node, which if node size is less than, is it less than equal 100,000, then size plus equals n size. So the idea here being that this lambda gets passed through to every single node in the tree, and our member or our lambda gets updated every time we call our function with a node. We haven't tried compiling yet. We're writing code for half an hour. Let's see how we go. Does it need mutable? Yes, it does need mutable. Where do you even write mutable again? I forget. Is it here? Yeah, you need to, if you have a lambda which has a member here which you want to, which captured by value, and you want to be able to mutate the member, then you need to write mutable somewhere. I can't remember exactly where. That part 2 is going to make me delete things. I don't want to do that. Null declared, undeclared event. Whoops. Okay. No matching call operator. Yeah, delete files and recompute sizes. You might be right. What am I doing? Find if. It's a unique pointer. Oh, you're right. Yeah. Oops. Okay. Current dir equals it get. Didn't really have to use unique pointers here. Like, it's a small program. It could just be like, you know what, I'll just let my program reclaim memory at the end. Oh, this is supposed to take a char. And here as well. Okay, this did not compile. Can't convert. Oh, because this is I need to say clause or size walker. You know, actually, I'll do size here and capture it by reference. And then I don't need mutable. And you can do that. Use of members default parameter requires static member. Okay. I guess what I'll do is have a version of this which does that. No overloaded function could convert all the argument types. Somewhere I am trying to copy somewhere. Where am I trying to copy? Line 22. need to pass a parent. A root node is gonna have null pointer as the parent. Am I doing this again somewhere? Line 17. Oh, whoops, wrong file. Line 17. No, line 27. Character, name. Anyone see what I'm doing wrong? Cannot convert string view to string. I think this is our only use of this anyway, so it's best to just take a string and move it. Not that moving these strings is really going to make any difference, especially because they're probably all going to fit in a small buffer optimization. No matching overload found for f and child.get. Hey, thanks for the subscription, Chip Collier. And we're trying to do a copy somewhere. Build succeeded. Okay, well, let's see how we get on. Debug assertion failed. Phenomenal. Okay, where am I? List dir. Oh, if list is the last thing, then while current front is not that, and current is not equal to end, but we don't have end at this point. Let's just shove it there. The problem here being that I assume we got to, which should mean that we should have our tree essentially created. Size 4838 something. 48381165. 48381165. Okay, so we did all our parsing correctly. We just had that little bug. Another debug assertion failed. Where are we this time? Same place. Wait to stick this check first so that we short circuit, because otherwise we're checking current front of a invalid iterator. 190290. That is not correct. Okay. So we got some debugging to do. That's fine. We can do debugging. Let's stick a breakpoint in our lambda here and just check the sizes that we're getting for our nodes below us. Make sure they're all looking good. Okay, so we start off and our node is root, which has big size, so we do nothing. Fine. Then we have A, which is 94853, so we should add that to size, which we do. Okay. And then we've got 584, which we should also add. Then we have 584 again. Is that all correct? Oh, that's a file. If n children dot empty, because we only want to do directories. So we were ending up adding all of our files as well as our directories. Let's just let this run, see if we get the right answer. 94853. Not quite. 94853. We're missing the 584. Why? Alright, back the breakpoint goes. Okay. So here's us getting A, which is correct. So where's the 584 supposed to come from? 584 is supposed to come from E. So then we should walk E, and we get 584. This is not empty because we want directories. You know what? So I don't make this mistake again if we need it in part 2. There. It's a fun one. I like messing with graphs and pointers and stuff like this. Alright, let's try this again. What did we get? 95437. 95437. Huzzah. Big number. Yay! Amazing. Okay. Oh, you're right. Very good. Now you're ready to choose a directory to delete. Total disk space available to the file system is 7 bunch of zeros. To run the update, you need unused space of at least 3 bunch of zeros. You need to find a directory you can delete which will free up enough space to run the update. In the example above, the total size of the outermost directory is big number. This means the size of the unused space must currently be a smaller number. Therefore, the update still requires a directory with total size of at least big number to be deleted. To achieve this, we have bunch of options. Directories E and A are too small. Directories D and root are both big enough. So you choose the smallest. Find the smallest directory that, if deleted, would free up enough space on the file system to run the update. What is the total size of that directory? Okay, so basically what we do is we our size to free is going to be was it 7 million? 70 million. That's the minus our CL dot root size. Root size. Okay, so that will be the size which we need to free. So we just want to change our walker slightly. I'll make a struct part2 or delete walker. Okay, so this is going to have a vector of the sizes, potential options. And our call operator is going to take a node n, which is going to do we also need our to free. I'll pass that in. So if the node size is, I'm just going to turn this radiator off. It's like -1 degree outside, but so I have 2 radiators at the moment, but it's getting a little bit hot. So if our size is greater than to free, then we're going to options dot push back n size. And again, we want only directories. Okay. So this should give us back our options, and then best option will return the smallest one, so std ranges min of options. So we're going to do our delete walker with our size to free, pass in our delete walker, and then output delete, walk dot best option. Let's try that. Wow, compiled first time? Really? Really? Don't trust it. Don't trust it. That's the same answer as the first one. Not the right answer. Did I save the file in time for the build? Okay, I got a different answer this time. Obviously, I did not save the file in time. And this is going to shout at me because I've not waited long enough to type in a new answer. Yep. 38 seconds. Well. Why don't we try this with the test input just to double check. So we're expecting D249. Yeah, 249333642. Yeah, that looks right. So did we get this compiling and giving the right answer first time? That would be cool. Nah, too high. Brutal, brutal. What if it's equal? Greater than equal to 3. Does that give me a different answer? 256. No, that's the same answer. Okay, so we're doing something wrong. Oh, this is the worst when you're when the test input gives you the right answer, but the real input gives you the wrong answer. How many things have we got here? Like, oh, no. Okay. So what did it say? Did it say it was two answers too high? So at this stage, like, we're trying to free. Okay, so we have two options. Okay, well, it's not either of those. Oh, I got a calculation wrong somewhere. Right, so let me just reread this. So you need unused space of at least 30 million. Ah, okay. So the amount to free is not 70 million minus our root size. It's what's the calculation we need here? The size of the unused space must $30 million minus this. Is that correct? That is the amount of free space so far, and we want it to be 30 million. So to free is that, let's just run it. Smaller number, promising. Oh, yay, that was it. Cool. I like this. Like, it's not the most terse of solutions, but I like that we got our, like, tree walker thing, which we could just plug a lambda or a struct into. It's quite a nice way of making this like reusable walker, so you don't have to embed this kind of structure in all of your tree walking stuff. Yeah, I'm happy with that. And we did it in 55 minutes, so I am gonna go and get ready for my appointment. And actually, one other thing is I did actually go and yesterday I was saying, hey, it would be nice if I had a adjacent view. Sorry, a sliding view. So I went and wrote one. It's kind of ugly. It's a couple hundred lines just make a sliding window, and the reason for that is that you sometimes have to cache the start or end of the sliding window depending on whether your underlying range is random access and sized, or it's bidirectional and common, or it's not. You have to do different levels of caching. So I have like base classes which potentially cache the last and the first parts of the window, and then I've got like cursor bases which if you're caching the first part, then you need to track some additional state, so that it's like I have a partial template specialization on whether slide has to cache the start, and then based on that I've got like more nonsense which where is it, when I do begin, like I switch on whether I'm caching first, in which case I have to like check my cache and then do some calculations, and it's doing like all different stuff for the different levels of caching, and it's just it's a mess. I pretty much implemented this directly from the paper which Tim Song wrote, I believe. Tim Song? Yeah. I don't know if it actually went forward, because I noticed there was a few things missing from the paper. Anywho, it seems to work. I wrote some tests. It would make this code a little bit nicer. Like, I wonder if this just works. So I would give it slide of n, and then I don't need to transform it to an array. I think that is the equivalent of what we had for oh, this is missing something for that case. What's this? TL functional. Okay, well, it doesn't just work, but anyway, it was because it doesn't return an array. Yeah, this would make stuff nicer anyway. I'll just revert this for now. If I made a bunch of changes, it would work. I'm pretty sure. Anyway, I'm gonna head off now. So thanks everyone for joining, and I will see you tomorrow.